Let's now review the substitution method. This will help us find x, y, and z when each is present in all three equations. So we can no longer use back substitution for these cases. So what we'll do is we'll first solve the first equation for one variable, and we'll always solve for x first. And then we'll substitute this expression for x into the other two equations, b and c. And by doing so, we will wind up producing a 2x2 system, equations d and e, in which our x has been removed, and now we just have y and z. And now with this 2x2 system, we'll want to use the substitution method to solve for y and z, and then use back substitution to solve for the third variable x. So we'll take the three equations, eliminate x so that we get a 2x2 system. We'll use the substitution method for a 2x2 system to find y and z, and then we'll plug y and z into a, b, or c to find x. So let's go back to the beginning with this same exact system and walk through it together. So you'll be asked to solve by substitution and check the answer. Equation A is x plus y plus z is equal to 4. Equation B is x minus y minus z is equal to 0. And equation C is 2x minus 2y plus 3z is equal to 15. So step 1, we want to take equation A and isolate x on the left side. So we have x plus y plus z is equal to 4. So in order to isolate x, we need to subtract y and subtract z from both sides, giving us x is equal to negative y minus z plus 4. And now that we have an expression for x, we want to substitute x into equations b and c here. And then step 3, we want to create a 2x2 system with the equations from this step. So let's first plug negative y minus z plus 4 in for x here in equation b. And now we've eliminated one of our variables x, leaving us with just our y's and z's. So we can create a 2x2 system by first combining our like terms, our y's and z's. Negative y minus y is equal to negative 2y. Negative z minus z is equal to negative 2z. So we wind up with negative 2y minus 2z plus 4 is equal to 0. And when we are creating a 2x2 system, on the left side, we only want the terms that have our variables. So we'll remove the 4 by subtracting 4 from both sides, giving us our first equation in the 2x2 system, equation D, which is negative 2y minus 2z is equal to negative 4. So now we'll put this equation to the side, and now we'll plug in our expression for x into equation C here to get our second equation for our new 2x2 system. So we want to distribute the 2 to each of these three terms inside of the parentheses, giving us 2 times negative y, which is negative 2y. 2 times negative z is negative 2z. And 2 times positive 4 is positive 8. Minus 2y plus 3z is equal to 15. And now we combine our like terms. Negative 2y minus 2y is negative 4y. Negative 2z plus 3z is positive 1z, or positive z. Plus 8 is equal to 15. And now to create the second equation in our 2x2 system, we want to move this 8 to the right side. So we subtract 8 from both sides, showing us equation E is negative 4y plus z is equal to 15 minus 8, which is 7. So now we have our new 2x2 system with equations D and E. So we want to use the substitution method on this 2x2 system to solve for variables y and z. So now we want to work with D and E So we'll put equations A, B, and C to the side for a moment. And now we want to isolate y on the left side of equation D. So we'll take negative 2y minus 2z is equal to negative 4. And we'll isolate y by first adding 2z to both sides, giving us negative 2y is equal to 2z minus 4. And now we'll divide both sides by negative 2, showing us y is equal to 2z divided by negative 2, which would be negative z. And negative 4 divided by negative 2 would be positive 2. So we get y is equal to negative z plus 2. So now step 5, substitute y into equation E here, and then solve for z. When we plug in negative z plus 2 for y, we get negative 4 times negative z plus 2 plus z is equal to 7. So now we only have z, so we can solve for z. But first we want to distribute the negative 4. Negative 4 times negative z is positive 4z. And negative 4 times 2 is negative 8. Plus z is equal to 7. We can combine the like terms, z and 4z, to give us 5z. And now we can solve for z. So we'll add 8 to both sides, showing us 5z is equal to 7 plus 8, which would be 15. And to remove the coefficient of 5, we divide both sides by 5, showing us that z is equal to 15 divided by 5, which would be positive 3. So now that we've solved for z, we can take z is equal to 3. In step 7, we can substitute z into equation D here, and then solve for y, step 8. When we do so, we get negative 2y minus 2 times 3, which would be negative 6, is equal to negative 4. And now we'll add 6 to both sides, giving us negative 2y is equal to negative 4 plus 6, which would be positive 2. To remove the coefficient of negative 2, we divide both sides by negative 2, showing us y is equal to 2 divided by negative 2, which would be equal to negative 1. So we use our 2 by 2 system to figure out that y is equal to negative 1 and z is equal to 3. So now that we know 2 of the 3 variables, we can substitute y and z into equation A, B, or C. You do not have to plug them into all 3. You can choose any of the 3 though to plug y and z into, and that will allow you to solve for x. So I'll show you that you get the same x for all 3. So I'll work through A, B, and C here. So if we plug y is equal to negative 1 and z is equal to 3 into equation A, we get x minus 1 plus 3 is equal to 4. Negative 1 plus 3 is positive 2. And now we subtract 2 from both sides, showing us x is equal to 4 minus 2, which is positive 2. So when we substitute y and z into equation A, we get x is equal to 2. You should get the same exact value for x if you plugged y and z into B or C as well. So I can show you that. So x minus negative 1 would be plus 1 minus 3. 1 minus 3 is negative 2. So we get x minus 2 is equal to 0. And to solve for x, we'll add 2 to both sides, showing us x is equal to 0 plus 2, which is 2. So we see that whether we plugged y and z into A or B, we got x is equal to 2. Same thing if we plug them into equation C, we would get 2x minus 2 times negative 1, which is positive 2, plus 3 times 3, which is positive 9. 2 plus 9 is equal to 11. So we get 2x plus 11 is equal to 15. And now we want to subtract 11 from both sides, showing us 2x is equal to 15 minus 11, which is 4. And to remove this coefficient of 2, we divide both sides by 2, showing us x is equal to 4 divided by 2, which would be positive 2. So we see that we got the same exact value for x, whether we plugged y and z into a, b, or c. So just choose one of them to plug those two variables into to solve for your third variable. And then we wind up with the solution. X is 2, y is negative 1, and z is equal to 3. In step 11, check the answer by plugging the x, y, z, 2, negative 1, and 3 into the original equations. When we do so, we get 2 minus 1, which is 1. 1 plus 3 is equal to 4. So the true statement 4 is equal to 4 confirms that these are the correct values for x, y, and z for equation A. For equation B, we get 2 minus negative 1, which would be 2 plus 1, which is 3. 3 minus 3 is equal to 0. So the true statement 0 is equal to 0 confirms that these are the correct values for x, y, and z. In equation C, we get 2 times 2, which is 4. Negative 2 times negative 1 is positive 2. And 3 times 3 is 9, giving us 4 plus 2, which is 6. 6 plus 9 is 15. So the true statement 15 is equal to 15 confirms that these are the correct values for x, y, and z. So the solution to the system is the point where x is 2, y is negative 1, and z is equal to 3. And that is how you solve a system with the substitution method. Let's now have you try a few practice questions. Solve by substitution and check the answer. Question number 1, equation A, x plus y plus z is equal to negative 3. Equation B, x minus y minus z is equal to negative 3. And equation C, 3x plus 2y minus 2z is equal to negative 5. Question number 2, equation A, x plus 2y minus 3z is equal to negative 15. Equation B, negative 2x minus y plus 2z is equal to 6. In equation C, 3x plus 3y plus z is equal to negative 3. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. Step 1, isolate x on the left side of equation A. To do so, we want to subtract y and subtract z from both sides, showing us x is equal to negative y minus z minus 3. And now that we have an expression for x, step 2, substitute x into equations B and C, here and here. So we'll plug in negative y minus z minus 3 here. That gives us negative y minus z minus 3 minus y minus z is equal to negative 3. So we can combine our like terms. Negative y minus y is negative 2y. Negative z minus z is negative 2z minus 3. And now we just want our y and z terms on the left side. So we'll add 3 to both sides, showing us negative 2y minus 2z is equal to negative 3 plus 3, which would be 0. So this is equation D. So we'll put that to the side. And now we plug in our expression for x into equation C. So we get 3 times negative y minus z minus 3 plus 2y minus 2z is equal to negative 5. So we begin by distributing this 3 to each of these terms inside of the parentheses, giving us 3 times negative y, which is negative 3y. 3 times negative z is negative 3z. And 3 times negative 3 gives us negative 9. Plus 2y minus 2z is equal to negative 5. And now we combine our like terms. Negative 3y plus 2y is negative y. Negative 3z minus 2z is negative 5z. Minus 9 is equal to negative 5. And now we add 9 to both sides, giving us negative y minus 5z is equal to negative 5 plus 9, which is 4. So now we have equations D and E, our 2x2 system. So we can use the substitution method on this 2x2 system to solve for these two variables, y and z. So we want to move equations A, B, and C to the side for a moment and work with just D and E. So now for equation D, we want to isolate y on the left side. So we'll add 2z to both sides, giving us negative 2y is equal to 0 plus 2z, which would be 2z. And to remove the coefficient, negative 2, we divide both sides by negative 2, showing us y is equal to 2z divided by negative 2, which would be negative z. And now that we have an expression for y, step 5, substitute y into equation E here, and then step 6, solve for z. So that gives us negative 1 times negative z minus 5z is equal to 4. Negative 1 times negative z is positive z. Z minus 5z would be negative 4z, and that's equal to 4. So now we divide both sides by negative 4, showing us z is equal to 4 divided by negative 4, which would be negative 1. So now that we've solved for z, step 7, substitute z into equation D here, and then step 8, solve for y. So that gives us negative 2y minus 2 times negative 1 is equal to 0. Negative 2 times negative 1 is positive 2. So now we'll subtract 2 from both sides, giving us negative 2y is equal to 0 minus 2, which is negative 2. And to remove this coefficient of negative 2, we'll divide both sides by negative 2, showing us y is equal to negative 2 divided by negative 2, which is positive 1. So now we've found the values for both y and z. Y is positive 1, z is negative 1. So now, step 9, we can substitute y and z into equation A, B, or C to solve for x, step 10. So if we plug these values into equation A, we would get x plus 1 minus 1 is equal to negative 3. Positive 1 and negative 1 cancel out, showing us x is equal to negative 3. If you substituted y and z into equation B instead, that would have given us x minus 1 minus negative 1. Minus negative 1 is positive 1, so that cancels out negative 1, leaving us with just x. So again, we get x is equal to negative 3. Or you could have chosen to plug y and z into equation C to solve for x. If you did so, you got 3x plus 2 times 1, which is 2, minus 2 times negative 1, which is positive 2. 2 plus 2 is equal to 4. So we get 3x plus 4 is equal to negative 5. And to solve for x, we'll subtract 4 from both sides, giving us 3x is equal to negative 5 minus 4, which is negative 9. And now we divide both sides by 3 to give us x is equal to negative 9 divided by 3, which is negative 3. So when you plug in y and z into A, B, or C, we get x is equal to negative 3, showing us the solution to this system is the point where x is negative 3, y is positive 1, and z is negative 1. And now, step 11, check the answer by plugging the x, y, z, negative 3, 1, and negative 1 into the original equations, a, b, and c. When we plug them into a, we get negative 3 plus 1, which is negative 2. Negative 2 minus 1 is negative 3. So we get a true statement, negative 3 is equal to negative 3, confirming that these are the correct values for the variables. When we plug them into equation b, we get negative 3 minus 1 minus negative 1, which would become positive 1. Negative 1 and positive 1 cancel each other out, leaving us with just negative 3 on the left side. And this true statement, negative 3 is equal to negative 3, confirms that these are the correct values for x, y, and z. And for equation c, we get 3 times negative 3, which is negative 9. 2 times 1 is positive 2. And negative 2 times negative 1 is positive 2. Negative 9 plus 2 is negative 7. Negative 7 plus 2 is negative 5, giving us the true statement, negative 5 is equal to negative 5, confirming that we found the correct values for x, y, and z. So the solution to this system is the point where x is negative 3, y is positive 1, and z is negative 1. So that is the answer to question number 1. Let's now have a look at question number 2. We were given the 3x3 system. Equation A is x plus 2y minus 3z is equal to negative 15. Equation B, negative 2x minus y plus 2z is equal to 6. And equation C, 3x plus 3y plus z is equal to negative 3. So step 1, isolate x on the left side of equation A. To do so, we'll need to subtract 2y and add 3z to both sides, showing us that x is equal to negative 2y plus 3z minus 15. And now that we have the expression for x, we want to substitute x into equations b and c here and here, so that we can create a 2x2 system with variables y and z. We'll distribute the negative 2 to each of these terms inside of the parentheses, giving us negative 2 times negative 2y, which would be positive 4y. Negative 2 times positive 3z is negative 6z. And negative 2 times negative 15 is positive 30. Minus y plus 2z is equal to 6. And now we want to combine our like terms, giving us 4y minus y, which is 3y. Negative 6z plus 2z is negative 4z, plus 30 is equal to 6. And now we want to subtract 30 from both sides, showing us 3y minus 4z is equal to 6 minus 30, which would be negative 24. So this would be our equation D. So we'll put that to the side, and now we'll substitute x into equation C here, giving us 3 times negative 2y plus 3z minus 15 plus 3y plus z is equal to negative 3. We'll distribute the 3 to give us 3 times negative 2y, which is negative 6y. 3 times 3z is equal to 9z. 3 times negative 15 is negative 45. Plus 3y plus z is equal to negative 3. And now we can combine our like terms. Negative 6y plus 3y is negative 3y. 9z plus z is 10z minus 45 is equal to negative 3. So now we want to add 45 to both sides, showing us that negative 3y plus 10z is equal to negative 3 plus 45, which would be positive 42. So now we have the 2 by 2 system that we will use to find y and z. So we want to move a, b, and c to the side for a moment so that we can work with d and e. And now we'll isolate y on the left side of equation d. So we'll first start by adding 4z to both sides, giving us 3y is equal to 4z minus 24. And now we'll divide both sides by 3, showing us y is equal to 4z over 3 minus 24 over 3, which would be 8. So now that we have our expression for y, step 5, substitute y into equation e here. And then step 6, solve for z. So when we plug 4/3 z minus 8 in for y, we get negative 3 times 4/3 z minus 8 plus 10z is equal to 42. And now we distribute the negative 3. The negative 3 and the positive 3 cancel each other out to give us negative 1. Negative 3 divided by 3. So we get negative 1 times 4z, which is negative 4z. Negative 3 times negative 8 is positive 24. Plus 10z is equal to 42. We combine our like terms, positive 10z and negative 4z, to give us positive 6z. Plus 24 is equal to 42. And now we'll subtract 24 from both sides, giving us 6z is equal to 42 minus 24, which is 18. And now we divide both sides by 6 to give us z is equal to 18 divided by 6, which would be positive 3. So now that we have solved for z, step 7 is to substitute z is equal to 3 into equation d here. And then step 8, solve for y, giving us 3y minus 4 times 3, which would be 12, is equal to negative 24. We'll now add 12 to both sides, giving us 3y is equal to negative 24 plus 12, which would be negative 12. And now to remove this 3, we divide both sides by 3, giving us y is equal to negative 12 divided by 3, which shows us that y is equal to negative 4. So now we've found that z is 3 and y is equal to negative 4. So step 9, substitute y and z into equation a, b, or c to solve for x. So I'll show you all three of these. So when we plug in y is equal to negative 4 and z is equal to 3 into equation a, we get x plus 2 times negative 4, which would be negative 8, minus 3 times 3, which is negative 9, is equal to negative 15. Negative 8 minus 9 is negative 17. So we wind up with x minus 17 is equal to negative 15. And now we add 17 to both sides, showing us that x is equal to negative 15 plus 17, which is positive 2. And we'll get positive 2 for x if we substitute y and z into b or c as well. So if you chose to plug them into b instead, you would have gotten negative 2x minus negative 4, which would be positive 4, plus 2 times 3, which is 6. 4 plus 6 is equal to 10. So we get negative 2x plus 10 is equal to 6. And now we subtract 10 from both sides, giving us negative 2x is equal to 6 minus 10, which is negative 4. And to cancel this negative 2, we divide both sides by negative 2, giving us x is equal to negative 4 divided by negative 2, which would be positive 2. So we get x is equal to positive 2 again. And you'll get the same value if you chose to plug y and z into equation c instead, giving us 3x plus 3 times negative 4, which would be negative 12, plus 3 is equal to negative 3. Negative 12 plus 3 is negative 9. So we wind up with 3x minus 9 is equal to negative 3. And now we add 9 to both sides, giving us 3x is equal to negative 3 plus 9, which is positive 6. And now we divide both sides by 3, showing us x is equal to 6 divided by 3, which is positive 2. So the solution to this 3 by 3 system is the point where x is 2, y is negative 4, and z is positive 3. And now step 11, check the answer by plugging the x, y, z, x is 2, y is negative 4, and z is 3 into the original equations. When we do so, for a, we get 2 plus 2 times negative 4, which is negative 8, minus 3 times 3, which is negative 9. 2 minus 8 would give us negative 6. Negative 6 minus 9 is negative 15, giving us the true statement negative 15 is equal to negative 15, confirming that these are the correct values for x, y, and z. For equation B, we get negative 2 times 2, which is negative 4, minus negative 4, which would be positive 4. So these cancel each other out, leaving us with 2 times 3, which is 6. 6 is equal to 6, confirms that our x, y, and z are correct here. And now for equation C, we get 3 times 2, which is 6. 3 times negative 4 is negative 12, plus 3. 6 minus 12 is negative 6. Negative 6 plus 3 is negative 3, giving us a true statement, negative 3 is equal to negative 3, confirming that we had the correct values in all three equations, and thus the solution to this system is the point where x is 2, y is negative 4, and z is 3.